Okay, so here we are looking at the Q code from Unit 1. And what we're going to do is try to figure out what kind of assertions we can add to this Q code that would make it more robust with respect to mistakes. So we go through the code, and this is the same code we already looked at. And what you can see is at the end, I've added a checkrep function. And what checkrep is a function that stands for check representation. And this is a function that we commonly add to a data structure or to other functions that checks the variables in the program for self-consistency. And so what it's going to do is basically trying to terminate the program if some invariant that we know should hold over the program's data structures fails to hold. What I first want to do, though, is run this program. And when I run it, what's going to happen is some testing code that I haven't shown you is going to create a queue and call its methods in a loop. And it's going to look at the output of the queue and try to find any mistakes. So the test function has a test oracle built into it that I wrote that's going to try to see if our queue is correct. So what we hope is that it's correct. And also, we know that the checkrep is going to succeed because it contains no assertions right now. So let's run. OK, so now that we've seen that our queue passes the test harness, let's see if we can harden up the queue a little bit by thinking of a good assertion to add to it. And so I think that the first assertion that we're going to add is going to be over the size variable. And if you recall from earlier, the size variable tracks the number of elements currently in the queue. So let's go ahead and add an assertion about the size. So one thing we know about the size variable is it should never be negative because we can't possibly ever have a negative number of elements in the queue. So let's assert that self.size is greater than or equal to 0. And the other thing we can assert about self.size is that it never exceeds self.max, which is the constant variable, which counts the most elements that could ever be in our queue. So here we're asserting self.size is not negative and doesn't exceed self.max. And so now when I run the test harness again, we're going to again check the queue for functional correctness and also call the checkrep. So let's see what happens. So it printed a finished over the old finished, and so that's good. OK, so that invariant was good. So what I want to do next is I'm going to break our queue. So I'm going to break our queue by making the enqueue fail to properly reset the tail variable when it overflows. So what we have here is logic that when self.tail is equal to self.max, we reset it back to 0. I'm going to set it to 1 instead. So let's see what happens when we run the queue now. So it failed. And what it did is it failed in an assertion inside the test harness. So this is in my test function down here on line 90. See, we only have 40 lines of this code. So way below is my test function, and we failed there. So what this means is we've messed with our data structure in such a way that it actually returns a wrong result. So this is a result not being equal to the expected result assertion. And so what we've done is we've created a data structure that's broken, and when it returns wrong results, this is going to be deeply buried in some program that we care about. So it's going to return the wrong results to some deeply buried part of the program, and probably that program is going to keep running for a while, and it's going to start to do very bad things. It's going to lose track of web pages, or it's going to start to do other things that we don't like. And so what we want is to write a tighter set of assertions for our queue so that our checkrep can catch this before we actually return the wrong thing to the user. And so this is your API quiz. Your API quiz is write an assertion that goes under mine in the checkrep, which catches the bug in the queue before it can actually misbehave. The trick you're going to have to do is, since our buggy code set self.tail to 1, that's in range. So another invariant besides saying self.size is between 0 and self.max inclusive is we could have asserted the same things for self.head and self.tail. But the bug here is not going to violate those particular checks. Rather, what's going to violate is a relative check between the values of head, tail, and size. And so that's what you should be thinking about to add your assertion here. And so what I want you to do is come up with the correct data structure invariant to assert here so that that assertion fails when we run our queue tester before we actually return a wrong result. And additionally, what we're going to do is we're going to check your assertion against a correct version of the queue. So we're going to take your checkrep code and put it in a correct version of the queue and check that it doesn't fail spuriously. So what we want to do is we want you to do is write an assertion that's tight enough that it catches the error that we've introduced here, but not so tight that it always fails. OK, well, I hope you'll have fun with this.